Well, here we have our Chapter 5 test review. You can obviously read through those topics. If you want to read them now, you can pause the video and read them, but those are the things that you will need to know. We'll start with these first questions, and these first questions have to do with the centers and segments that we talked about within a triangle. So be very familiar with this chart and be able to pick out the different things and answer the questions. So we can go through this. Number one, it says fill in the blank. The blank is a segment that goes from the vertex to the midpoint of the opposite side. Well, if you know your table well, you know that is a median. So realize it's asking for a segment. Please put segments when it's asking for segments and put points when it's asking for points. So a median, that's the definition of median, is a segment that goes from the vertex to the midpoint of the opposite side. The blank is a segment that goes from the vertex perpendicular to the opposite side. Well, using your chart, you know that that is an altitude. And hopefully you don't need to use your chart anymore. The blank is the balancing point. That's the centroid. The three altitudes of a triangle meet at the orthocenter. So make sure you know this chart well enough so that you can answer these questions pretty quickly. The three perpendicular bisectors meet at the circumcenter. So these are just sample questions. You could have questions that are asking about any of these different segments, the points, or the properties. The three medians of a triangle, number 6, meet at the centroid. The three angle bisectors of a triangle meet at the incenter. The blank is equidistant from the three vertexes or vertices of a triangle. Well, which was the one that's equal to the three vertices or vertexes? That is the circumcenter, because then it would be the center of the circumscribed triangle. And equidistant to the three sides, that's the incenter, which is the center of the inscribed triangle. All right, so that's using that chart that you guys have filled out. Make sure you know all those different things, definitions, points, and properties. Next, we're going to be using a couple of theorems here, which was kind of 5.3 to 5.5. Solve for E. Well, we learned that an exterior angle is equal to the sum of the two remote interior angles. So we can go ahead and write that 77 has to equal E plus 19, and we would subtract 19 from both sides. And we get E is equal to 58 degrees. Next one's the same concept. This 101 degrees is supposed to be this angle here. So we know from the exterior angle theorem that 101 is equal to 6V plus 59. We can subtract 59 from both sides. And we get 6V is equal to 42. Divide both sides by 6, and you get V is equal to 7. So this says solve for Y. I'm guessing that this got cut off here, and this was supposed to be a Y, so we actually used V. I apologize. Number 12, state the largest and smallest angle for triangle USE. So it might help to sketch this. You don't really have to if you know your things well. USE, so US is the longest, so let's make that, this is US. which would make this E. It might not be completely drawn to scale, but this is, I don't even know if this is the longest, but this is 19, EU is 16, and SE is 14. So definitely not drawn to scale, so we need to go by the lengths that are given. So the largest angle is definitely across from the largest side. 19 is the largest side, so the largest angle is angle E. And the smallest side is 14, so the smallest angle is angle U. So that was the theorem that tells us the largest side is across from the largest angle and vice versa. On to the next examples here. In triangle RST, angle R is 72 and angle S is 57. List from shortest to longest. Well, same idea. So I'm just going to draw on RST. S was 57 and R is 72. We can use those two, add them together, and we'll subtract them from 180 because that will help us find angle T. That's going to be 51. So angle T is 51 degrees. So we want the shortest side to the longest. Shortest will be across from the smallest angle. The smallest angle is T, so the smallest side is SR or RS, either one. Next smallest side is, our angle is S, so RT would come next. And then the longest side would be across from the 72, which is ST. We've seen this figure before. Use the figure to give the proper name for each segment. So the different segments are altitude, angle bisector, median, and perpendicular bisector. We see some information here that we have right angles. We also have some information to the right. AF is the same length or is congruent to FC. So that means F is the midpoint. And then we also see that angle ABE, that's this angle, is congruent to angle EBC, which is this angle, which means that if those angles are congruent, BE has to be the angle bisector. So let's go ahead and write that in there. BE is the angle bisector. BD, let's take a look at BD. We'll do this one in black. BD is right here. It goes from a vertex and is perpendicular to the opposite side. Well, that is the definition of altitude. And BF, let's look at that one in orange. This goes from a vertex. Oops, BF, that's this one, and goes to F, which we figured out was the midpoint. Well, it goes from the vertex to the midpoint, the median. And the last one, GF. GF is the only one that doesn't have to go through a vertex. It can sometimes, but doesn't have to. That splits it in half and is perpendicular, so that's the perpendicular bisector. All right, these next few questions, the next 4 questions, in fact, have to do with the triangle inequality theorem, which says the two smaller sides, really it says any two sides must add it to be larger than the third side. So we're going to look at these. We have 10 and 12 are smaller, 10 plus 12, and they're all in feet. Oops, 10 plus 12 is 22. 22 is greater than 18, so yes, this can form a triangle. 3 feet plus 6 feet is 9 feet. That's not big enough. It wouldn't form a triangle. It would look something like here's the 10, here's the 3, and here's the 6. They wouldn't reach. So this is a no. Wouldn't form a triangle. 1, 6, and 6. Well, there's not 2 smaller, so just 1 plus 6 has to be larger than 6, which it is, so that's a yes. If you think about this, this would be an isosceles triangle with the base being much shorter. All right, state the possible lengths for x if three sides of a triangle are 18, 7, and x. Well, we talked through this and worked through this when we learned it, and we then figured out a nice little way to remember this. We can put x in the middle with less than signs, and what you do is you subtract 18 minus 7 to get this side, so 18 minus 7 is 11. So 11 is less than x, and x is less than, and then you add 18 and 7, which is 25. So x has to be between 11 and 25. You could have written it in words between 11 and 25 if you're not as comfortable with the inequalities, but you really should be able to write the inequalities. Getting close to the end here. Find x if Lj equals 3x minus 9. Lj is 3x minus 9. That's this whole thing. And dj is 2x minus 9. Now, apparently I forgot some directions here. These are the medians. So dk is a median. NC is a median. So I apologize for that. So those are medians. Well, medians we know go through the midpoint. So dj is 2x minus 9. So LD has to be 2x minus 9 as well. So we could say 2x minus 9 plus the other 2x minus 9 is equal to 3x minus 9. We could have written that as a different way, like 2x minus 9 times 2, but this will work just fine. So we have 4x minus 18 equals 3x minus 9. We will subtract 3x from both sides, and we can also add 18 to both sides. And that gets us to our answer that 4x minus 3x is x. This is 0, 0. Negative 9 and 18 is 9. So x is equal to 9. Actually, I still didn't finish all the directions. NC and MD are medians. So we know DM is 2x. This whole thing is 2x plus 2. And then HM, which is just this part, is 2x minus 6. Well, what we learned is that H would split this into a ratio of 1 to 2. 1 to 2. So that's 1, and then there would be 2 of those. So 1, 2. So there's a couple different things we could do, but since it's like that, we have 3 of these lengths. I tried to separate them so you would see them. So there's 3 of those lengths. So we could say 2x minus 6 times 3 has to equal the 2x plus 2. And then we just solve. So we have 6x minus 18 equals 2x plus 2. We'll go ahead and subtract 2x from both sides. 4x minus 18 equals 2. We'll add 18 to both sides. We get 4x equals 20. So x has to equal 5. You might see different variations of that. Maybe you would know like this length and this length. And so you would have this one plus itself equals the long one. So there's different ways that you could see that question. All right, refer to each figure, Write an inequality relating the given pair of angle or segment measures. All right, so this has to do with the Hinge theorem. As we finish up here, we finish with the Hinge theorem and its converse, which basically says if two sides of one triangle are congruent to two sides of the other, and one way says, and you know the two angles, like one angle is bigger than the other, the side across from it will be larger, or vice versa. So in number 23, we do see we have this side congruent to this side and this side congruent to itself. So that's two sides of the left triangle congruent to two sides of the right. We see that 10 is greater than 7, which means angle 1 would be greater than angle 2. We cannot always go by how it looks. Drew. Next, same idea. Because we know two sides, so 5 is congruent to 5. FH is congruent to itself, and then we see that 8 is greater than 7. So once again, angle 1 will be greater than measure of angle 2. It won't always turn out that way, but so far it has. Number 25. This time we have a side congruent to a side and another side congruent to itself. But now we have the angles. Obviously 26 is greater than 24, so ZB is the bigger one. So we would want to write a less than sign here. So XB is less than ZB. Suppose you also could have written ZB is greater than XB. And notice I didn't put the segments on top because I'm talking about measures. You don't put segments when you're talking about measures. Next one, two sides congruent to two sides. And we have an angle here of 85, an angle here. It doesn't write the number, but it's got the right angle, so this is 90. Obviously 90 is greater than 85. So HJ has to be the larger one. HJ is greater than KP. We have an 8 congruent to an 8. Reflexive property, this is congruent to itself. And we see, obviously, that 9 is greater than 5, which means angle 2 is the larger one this time. Angle 2 is greater than measure of angle 1. Or you could have written measure of angle 1 is less than the measure of angle 2. Either way is fine. And then the last one. 16 is congruent to 16. Interesting. This is an isosceles triangle here in the middle because the base angles are equal. So this segment's congruent to this one. We had to think a little bit more there. Still works out. And then we see, this is a little bit confusing, but these are measures here, 3 and 4. So 6 is bigger than 5, which means measure of angle 4 is greater than the measure of angle 3. And there you have it. Answers for the test review. Make sure you're ready.